A very pleasant evening to all distinguished panelists and participants. Bharti Vidyapeeth's Institute of Computer Applications and Management, BVI-CAM, in association with Computational Intelligence Society, CIS chapter of IEEE Delhi section, Computer Society CS chapter of IEEE Delhi section, Technology and Engineering Management Society, TEMS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology Site Standing Committees of IEEE Delhi section, Region 10 of IEEE with the Associations of Computer Society of India CSI, Institute of Information Technology Professionals IITP, ISTE Delhi section and IETE Delhi Center as technical collaborator welcomes you all to the IEEE IETE BVI-CAM technical lecture series on From Keyboard Jockey to Prompt Pirate, Surviving the AI Native SDLC. According to AI itself, AI native SDLC empowers every stage of the software development lifecycle, requirements, design, development, testing, through intelligent tools that drive automation, efficiency, and quality, accelerating enterprise innovation and technological advancement. In a world where large language models refactor, document, and even debate our code, what's left for the human engineer? This session is aimed to provide a fast-paced tour of the AI native software delivery lifecycle, unpacking new skills, fresh failure modes, and why talking to the model may soon outrank typing the method. Expect real stories, sharp humor, and a survival kit for staying indispensable when the bots ship faster than you do. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome amongst us Professor M.N. Huda Sir, Director, Bharti Vidyapeeth's Institute of Computer Applications and Management, BVI-CAM, and Chairperson, IEEE Delhi Section, to address the participants with his inspiring words. Over to you, sir.
Good evening, one and all. It's my privilege to welcome you all in 173rd episode of BVI-CAM IEEE IETE CSI weekly evening webinar series. And at the outset in this webinar series, 173rd edition, I take this opportunity to welcome today's valued speaker, Mr. Srinivas Bhaskar, who is part CO, part code, Whisper, part AI, who will be sensitizing us the entire journey, right from keyboard jockey to prompt kind of environment now. All of us have started using ChatGPT, started using, in a bigger term, the generative AI, and this is a huge shift, paradigm shift from what we started from a fundamental keyboard. Dear friends, this webinar series was started 5 years ago, 20th May 2020, and today is 24th May 2025. So 5 years and 4 days. When in 2024, IEEE US started adjudicating and analyzing various such events started all across the world. They invited nominations and we also submit nominations. After analysis and adjudication, they gave to this webinar series. This webinar series was adjudicated as of the one of the most sustainable and best webinar series started anywhere in the world. 172 editions have already been conducted, and we are today part of 173rd edition. Dear friends, Continuing a program is not easy. For that, the very first, you need to have so many speakers. You need to have a dedicated team. And for that, I'm grateful to my team who works at the back end, led by Dr. Ritika, and my great resource person who keeps on connecting me with the resource people for such webinars, Mr. Ajay. I only need to tell him that next 5 webinars are to be arranged, and he finds way. He requests people. Believe me, anyone who gives time and comes to our platform as a resource person, shares his or her knowledge, is not an easy task or is not a simple work. This is their commitment, this is their passion for connecting with the people, sharing knowledge, that what they accept our invitation and they are here. So I'm grateful to all of them from various parts of the country and abroad who keep on attending program one after another, depending upon interest of their subject and the topics. Dear friends, I always say that there is nothing constant in this world except change. And if we do not change up front, probably the rapidly changing ecosystem, rather technologically changing ecosystem, will change us. And today's topic is part of that, that is technologically changing from keyboard to prompt response kind of environment. And that's why I say that इंसान घर बदलता है, लिबास बदलता है, रिश्ते बदलता है, दोस्त बदलता है, फिर भी परेशान क्यों रहता है? इंसान घर बदलता है, लिबास बदलता है, रिश्ते बदलता है, दोस्त बदलता है, फिर भी परेशान क्यों रहता है? क्योंकि हम अपने आप को नहीं बदलते. एंड दैट्स हाउ गालिब सेड दैट उम्र भर गालिब यही भूल करता रहा, धूल चेहरे पे थी और मैं आईना साफ कर. So we cannot keep on believing in the keyboard kind of response environment. We have no choice but to believe and live in the changed ecosystem, and the changed ecosystem is the prompt kind of environment, for which we have invited Mr. Bhaskar here to share with all of us that what is the journey of the change and how this change is embracing each one of us, and what is the future and how we should be adaptive and how we should be prepared enough to get most out of these changes. Thank you so much. Keep attending our webinar. That keeps on motivating to all of us. Thank you so much. Wish you all the best. God bless you all. Over to you, Dr. Ritika, please.
Thank you, sir. With your motivating words, I would now welcome amongst us our expert speaker, Dr. Srinivasa Bhaskara, sir, with an e-booking.
Thank you, Dr. Ritika. Should I share my screens?
So just a minute.
Yeah.
Okay, full of multiple colors. Okay, share kiya?
Yes, sir.
बुके
I
के लिए
think
मैंने
there
दो
has
पंक्तियां
been an issue. I'll share it once again.
बुके के लिए मैंने 2 पंक्तियां लिखी हैं. जब हम फिजिकल मोड में प्रोग्राम किया करते थे तो बुके देते वक्त एक दूसरे की वार्मथ का एहसास किया करते थे. वो वार्मथ मिस हो रही है, लेकिन उस वार्मथ को हम वर्चुअल वर्ल्ड में फील कर सकते हैं, जिसके उस खुशबू को फील कर सकते हैं, उस जज्बे को फील कर सकते हैं जिस जज्बे के साथ ये बुके एक दूसरे को दिया जाता है. ये मल्टीपल रंगों का जो एक समागम है जो हमें फ्रेश और ताजा रहने के लिए प्रेरित करता है, इसको हम फील कर सकते हैं. इसके लिए मैंने 2 पंक्तियां लिखी थी कि बड़ी मुश्किल में हूं कैसे इजहार करूं, बड़ी मुश्किल में हूं कैसे इजहार करूं, तू तो खुशबू है कैसे गिरफ्तार करूं. तो खुशबू को हम कहीं गिरफ्तार नहीं कर सकते. कोई कंट्री की सरहद या ज्योग्राफिकल बाउंड्रीज इसे रोक नहीं सकती. तो खुशबू आप तक पहुंच रही है और आपके वार्मथ का एहसास मुझे हो रहा है. इन्हीं एहसासों के साथ ये बुके प्रेजेंट किया गया. थैंक यू सो मच. ओवर टू यू डॉक्टर.
And Professor Huda, that too, this Khushbu is reaching New York in USA. Bhaskara is based out there.
क्या बात है, क्या बात है. इमेजिन खुशबू न्यूयॉर्क तक पहुंच गई है और आज स्पीकर न्यूयॉर्क से हमारे साथ कनेक्टेड. वंडरफुल, वंडरफul.
Absolutely. Mr. Srinivasa Bhaskara is the kind of guy who can design a platform strategy before your coffee's brewed and then review your pull requests just to keep you honest. He's lived in more countries than you have perhaps visited, speaks fluent cloud native, and can make Gen AI feel like an old friend. He's not into fluff. He's into frameworks, outcomes, and the occasional Git commit. Yes, still, if you're looking for someone who is just as comfortable in strategy war room as in VS Code, hacking a plugin, Bhaskara's already halfway there. We are honored to have you amongst us, sir, today, and I would now request you to kindly enlighten the house. Over to you, sir.
Thank you so much. Should I start sharing my screen?
Yes, sir, please.
All right. Assume that you can see my screen now.
Yes, sir, we can see
All
your
right.
screen.
Awesome. Thank you so much. Honestly, I mean, to be completely candid, I do have butterflies in my stomach. And it's kind of interesting because exactly 30 years ago, about the same time of the year, I was preparing for my finals, in my fourth year of engineering. And so I had the same feeling, especially with the faculty that that I was going up against. So yeah, I do have that. And if there are some, I would say, missteps or mistakes, I appreciate that you would let me know on that. But the little bit of a difference I would say now is the deja vu of college is of course there. But I do have a friend, a co-pilot that comes along with me now, which is a good thing. I'm not all by myself as I was 30 years ago. So thank you again very much for the opportunity. I do sincerely appreciate and I'm deeply honored to be able to have this session over here. The the way that I would look at this is, as the professor mentioned, there've been a number of different changes over the years, over the decades where this has started. Honestly, when I started, about 85 is when I laid my hands on a computer first, and the work that I did then was on an 8-bit computer, a Sinclair ZX Spectrum at that point in time. And then subsequently, there have been so many inflection points in the journey of how computers and software have come across to. And today we are at a huge inflection point. And the inflection point is dramatically changing the way that we work with the introduction of the large language models. About 3 years ago, this inflection point is actually quite significant. And if you look at history, one of the things that where you would find a similar kind of an inflection point was around the 70s and the 80s. For those who may remember or who may read about this, there used to be a large number of people who we were calling as switchboard operators. And all they did was, take incoming calls, plug them to another one. And these were like people by the thousands, tens of thousands of people across the world who were doing this job. And there was the introduction of the automated, phone exchange. And that suddenly, almost overnight, eliminated tens of thousands of jobs. But it's not like the jobs were lost. The jobs were repurposed to something else. And that's the important part in every inflection point in history where technology has advanced to a degree, where there's been this, I would say, a threat or a worry of displacement of jobs. It's actually new jobs have been created, newer job archetypes have been created, and the number of employment opportunities have actually gone up because of that. So it may seem like that during the times that we are right now, with the whole LLM world, but it really isn't. And you'll find out some of that is how do you deal with that, as you go ahead. So just a little bit about me. I kind of took to computer engineering with my dad pushing me, in the 80s when I was in school. I still take pride as being an engineer today. I still dive into code as much as I can with my teams. So, don't go by a title. Literally, I'm an engineer. I will always remain that. But in the course of where I am, obviously, technology keeps changing. So where I see myself today is in terms of how do I prompt my way to get a computer to do something that I needed to rather than write the code for it. And in that sense, my past in my career has also included me working at the Boston Consulting Group as a consultant. So I do have a fair amount of experience in the strategy side, as well as being an engineer, and with some of my own startups, obviously spend a lot of time in code. So I'm pretty comfortable, in that mix between the two sides. So this is, I would say, I was just thinking about different ways to kind of, as a I would say a breaker for this session. And to be honest, this is the first time I'm actually doing a more or less one-way presentation. Usually I have an audience in front of me, or I have feedback coming back, or questions being asked. So I understand that we're going to park that towards the end. This is where I would ask the audience in terms of like, the best way to predict the future of code is to auto-complete it. What does that mean for us? What does it mean for the developer? What does the developer do? Think about this in yourselves in terms of like what you do, whether it's rudimentary programs that you write to help yourself, or whether you're doing this as part of your career for your for your business or for your clients. But just think about it in that sense, and does it settle you? Does it excite you with where you are? Because all of us literally are in the cusp of another major revolution, right? I mean, that's the inflection point that we're talking about. So just food for thought as you think through the kind of questions that you may have and what you want to bring up. So I have one small video, and this came out from the Microsoft Build conference that happened last week. And I want you to reflect again on this in terms of whether does this worry you? Does it pique your curiosity? Something that I want you to think about. I'm sorry.
I want it, I get it.
Right. Was it inspiring or scaring? You certainly have a lot that is done by somebody else, an agent that you can just, depute this to. Pretty phenomenal, huh? But this is not even the tip of the iceberg. There are more things happening. Google, in their kind of recent conference, has, announced the release of Mariner. I'll talk a little bit about that a little later. There's a whole lot more possibilities that come from there. Kind of like this is, again, food for thought for you to think about the questions that you may have coming out from this. And so largely what we'll do in today's webinar is in terms of like, one, let me walk you through in terms of what does the AI native SDLC look like, and how is that different from what we've been doing traditionally? What does that mean for the engineer? How is that changing from how an engineer looks at it, and how do they need to work? We'll take a couple of use cases, across the SDLC and talk about that bit. But principally, because this world is moving away from largely when we looked at computers, and I'm sure that in the curriculum we learned from it being extremely logical, everything is ones and zeros, bits and bytes and stuff like that. And so we kind of have grown up, or at least I've grown up in this very deterministic world when we talk about engineering. Now you're entering, it's not deterministic, it's a stochastic world. So there is no definite outcome when you talk to a computer today, or in this world, as compared to the past world. So what does that mean? I mean, obviously there's a whole lot of challenges that come into it, both from a practical nature, but there are also challenges that come into it from an ethical nature, as we will go through some of those things. And what does it mean from teaching methods? It is going to change in terms of how the pedagogical, models that we look at, and what does it mean for academicians, is how they work with their students and so on, and the new skills, for this era. And of course, there's a whole range of, open-ended questions in terms of what next? What does this mean for research, for academia? What does it mean for our careers as well? So hopefully we'll touch upon this a little more in the breadth of the space rather than the depth of it. But we can certainly dive in if you have questions, into the depth of it. So In terms of traditionally, we've always looked at software development in a kind of a linear fashion where we go from requirements to design, we look at implementation, we look at testing that out, then we want to deploy it, and then we want to monitor it. Now, the models or the way that we've gone about doing these phases when it comes to development has also changed over time. Probably you've heard of the waterfall model, you've heard of the agile model, you've heard of Kanban boards, the number of different ways in which people were looking to attempt how do we make sure that the software development lifecycle delivers the concept or the idea or the requirements that the consumer had in mind, or somebody thought that a consumer would have in mind, right? Over the years, or over the decades, there have been various attempts, and I would say attempts because there's no silver bullet, there's no single way to make sure your software is being delivered the right way. So there have been various attempts at trying to make this happen. Because of where we are currently and the inflection point that we are at a significant place where this is completely changing the way that we develop software itself. It's also going to affect the phases as what we do in those phases. For example, when we look at requirements, it would mean somebody like a product owner or a business analyst understanding what a customer wants, type in what we call as a user stories or broken up requirements, give it to an engineer. But in the new world, you're looking at like a conversation like this that we're having now can be translated or converted into a set of requirements for an engineer. Now that's a huge change. That's a big change. That's one of the changes, right? Similarly, when you're looking at design, we've had wonderful visual designers. One of my sisters is an extremely good artist, not from the computer side, but the other side. And then suddenly you're looking at all these LLM models being able to do that so easily and so well. So what does that mean, for the development lifecycle and so on? When you look at how you write code, you just saw the video that came out from GitHub Copilot. It does most of it for you. So what do you do then? As that engineer, how do you respond to the changes that comes in, right? You're moving from what was an automation of steps, you're moving into an automation with context and reasoning. It's interesting when you look at it that way, because now you're starting to think about it from, I'm talking to another potential human or someone human-like, right? And this means that it's not just step-by-step instructions. I'm actually talking to that other being in terms of context and in terms of reasoning. Very different when you look at it in terms of how you would approach the SDLC. So this is something which, again, you need to let it kind of sink in terms of what does that mean. The more that you're able to break out of the mold of the traditional thinking of how you approach software development, the better the possibility for you to accept what is the art of the possible. Because where we are today is literally pushing the art of the possible. So you have an aspiration of what you want to go after. The art of the possible is going to help you get there, providing you can break out of the traditional norms or traditional constraints around how to go building that. So what does it mean for the engineer, right? So in terms of like the key responsibilities, and this is where I would have thrown some questions to the audience, I'm going to kind of give some of those answers myself. So when you look at like key responsibilities of an engineer today, usually what does it mean? I need to understand the requirements. I need to be able to write good, clean code. I need to be able to structure the code, modularize it. I need to be able to test it to make sure that it's doing what I want it to do or what my customer wants it to do, and so on and so forth, right? I need to make sure it's running stable in the environments that I deploy it to. But this is shifting already. And a lot of that shift is coming around because you're moving from code, which means you're writing code. You're moving towards, you have an intent and you're looking to express that intent in prompts. Now, prompts is literally like, you can look at it as you're talking to another being. Now, how do you tell the being or communicate to the being? In this case, it's using prompts. Similarly, because that you have many different variations of this LLM agent, whatever word that you want to use for it. I call it as a powerful alter ego. I always have a couple of them with me at all times. And so it's also determining as which is the best model that you need to talk to for the given intent that you have. how do you make sure that the output that comes out of it is something that you verify? Because you obviously are not going to take it at its face value, right? I mean, humans inherently revolve between how much you trust other people and how much you don't. And you take some people for granted because you understand you've built a trust factor with them. And for some people, you don't trust them entirely, so you verify what they say. So it's a similar world that you're coming down to. And all of this comes down in terms of like, how does the code work, or what is the code and what is the context? You need to be able to bring, as I said in the previous slide, this is about context and reasoning. This is not about instructions of step-by-step instructions. So that's important. So the new mantra that you got to keep in mind here is in terms of, yes, you trust the agent, but you're going to verify the commit. So this is a play on, you know, trust but verify. I'm sure that many of you have heard of this. We use that in many different contexts. So that's something for you to keep in mind, is saying, yes, you want to trust the agent, but you definitely want to verify the commit that it makes. This is like, I didn't mean to overwhelm anybody over here, but honestly, when you look at the entire SDLC, the cognitive load on the people within the SDLC is actually extremely large. There is, one, a huge number of things that happens in any SDLC, and two, that there are a number of different activities and things that they need to do, and three, the number of tools that are available. Now, into this mix, because of the inflection point that we are at, you now have generative AI tools that are coming into the mix. Some of the traditional tools, sorry, are imbibing generative AI features. Some of them are not, and then you need to look at another tool to do that. So this is a fairly busy space. And currently, with where we stand and the amount of money that's being put into this quote unquote hype around AI, also means that you have tools coming out almost every day or every other day. And this inevitably leads to what we call as tooling fatigue, because of the churn in the number of tools that are coming to the surface. So you can't keep flitting between one tool that says, oh, I'm very good at doing this, and moving to another tool that says, oh, I'm great, so you drop this tool. You can't. So you need to think about, how do you construct this into the world as you're coming at it as an engineer or as a product owner or any of those kinds. So let's take a couple of examples, right? I mean, when we look at, let's say, requirements capture, fundamentally, beginning of an SDLC comes out with, okay, what's the requirements? You know, how do I do that? And so typically you would find product owners or business analysts, spending hours in terms of whatever that I've learned or I've heard from my customer is being translated into a exhaustive Word document. I mean, if I go back 20 years and I saw some of the requirements documents as we get from my customers, they used to be huge. I'm talking about like tens of hundreds of pages. Obviously, then you take that and break that down into requirements or into stories or into bite-sized chunks that an engineer can understand and do. So in this world, I mean, you could use things like Whisper, which is a model from OpenAI. It's now integrated into OpenAI. You have some kind of a transformation that goes into it. And voila, what you get at the end is like a set of generated user stories, and not only a set of stories, but also a set of acceptance criteria that comes along with that. And this has resulted in in a huge amount of savings. I mean, everybody has different extents to which they find their savings, but the most important part over here is not just the time savings. It's about how quickly you can get from a customer expressing an intent, let's say over a phone call or a conference call like this, and be able to translate that into a set of requirements that the engineer can do something about. So this is one such example when it comes to requirements. So similarly, we lived in a world where we've had about 30, 40 years of code that has come in. I mean, you've all heard of what should scare all of us, that the lifeline of our banking systems is based on systems that were built 30, 40 years ago. They use COBOL, which I'm guessing that academia doesn't teach anymore now. It used to be taught when I was learning, and languages like Fortran, and these are still there. So how do you move these legacy systems and bring them into the new age? And that's a familiar problem that most engineering companies and most software services companies typically look at for their customers. So it's hard, right? So how do you go about cracking this? And this is another place where the usage of these tools and the effective usage of these tools make a huge difference. So in this case, refactoring C++ modules and move them into Rust, that's a great way to look at it. I mean, Rust is far better than what C++ is, so on and so forth. So you don't want to modernize it. So how do you modernize it? You could use tools like GitHub Copilot, the one that you just saw on the video. You would obviously need to know how to work with it, which means you would have prompt templates that you would come about. And similarly, you would have things that you look at what kind of, I would say, code that is generated during the migration. You do want to validate that. That's the role that you play. And it results in a significant amount of time savings. What it also gives you as a benefit, because you are taking this superhuman kind of capability that augments what you do, you also have a large reduction in the risk. So that's another important part of the gain that you get out from such a use case. And this is like, again, requirements, and then we've gone to legacy, then comes to testing. And this is where, for those of you who may have seen the Google announcement on Mariner, or if you've seen OpenAI's ChatGPT operator that came sometime back, the evolution of testing is kind of interesting, because there's a lot of conversations that happen around unit testing, code testing, system testing, and so on and so forth. Honestly, the single biggest testing that is the most important one is the one that the end user does. And this has always been a hard problem to solve, because how do you emulate what a user does? So people have ways to automate the browser, automate an application, try to play the role of an end user and take them through the user journeys and so on and so forth. Now, in this world, because of where we are today, you can actually use LLMs to do that. And you can use LLMs, what we call as multimodal LLMs. And these are LLMs that not just interprets text, but is also able to interpret video, is able to interpret audio. And in that process is able to significantly change the way that we test our applications today. And so this intelligent testing brings about a whole lot of benefits from it, because one, it's able to simulate these as end users, which is phenomenal. Second, you don't have to tell it that this is how an end user is. It can actually intelligently figure it out on its own. Obviously, there's some trial and error, but it's able to do that on its own. And that then leads to a lot of, obviously, savings. It leads to lesser defects. You're able to catch it much more in time rather than post time. Like most testing tends to happen after the fact. And this allows a lot of that testing to happen, in fact, at the time that this is actually being generated. And the last use case that I would take is in terms of observability. Now, when you deploy these systems or solutions, some of them that we use on a day-to-day basis, let's say, the WebEx that we're just using now, it's a huge complex system that's deployed. A vast number of resources, a lot of network power, a lot of computing power that's kind of running all across the world. So even in the AI world, we haven't yet reached the part where this is something that is seamlessly done or very easy to do. So this is where, again, because of the capabilities of LLMs and the fact that it can do pattern recognition so much faster than humans, the fact that it can process and connect things as long as you give it the right kind of context, is where the LLMs find a large number of use cases where they can actually help in terms of how observability works in production as well as in the operations. So, the example of alert fatigue and slow root cause analysis is typically afflicting on humans. We have developed systems, and we do use those systems to be able to help us with this, but it still requires a lot of human processing to actually zero down on why something went down. Some of you may have heard of CrowdStrike when it had an issue patching some systems, and then it took down a whole lot of websites, a whole lot of services and applications across the world, right? Most Windows applications, Windows systems could not even start because of the CrowdStrike issue. So how do you go about resolving something? That's where LLMs kind of like give you a lot of power from the logs. You're able to interpret what the logs are, it is able to interpret what the logs are, be able to draw the context within it, and be able to very quickly get you down to what is the root cause for this issue. And so what we call is the mean time to recovery kind of goes down significantly. And that's huge. So these are like 4 broad use cases within the SDLC. Just before I go on, Dr. Ritika, how am I doing on time? Sorry, I've not been keeping track of it.
So we have around 20-25 minutes still, so you
Okay.
can easily go on.
Okay, sure. Sounds good. Thank you. So having said everything that we did, right, what we looked at, we now need to also consider what are the practical challenges that come with it. And I'm sure this is a word that most of us have heard more than we probably would have wanted to hear in the LLM world, which is hallucinations. Right? Everybody talks about hallucinations. Honestly, when the first time I came across this word within the LLM context, and people talk about hallucinations, I'm like, no, that's a bug. That's a mistake by the system, and the system is the ChatGPT. The thing is that ever since ChatGPT came out, I think that was November 2023. The way that it launched the system, 2022, sorry, the way that it launched its system was that it gave you a kind of a human-like chat behavior, right? And that kind of led many of us and most of us to think and work with these systems as very intelligent humans. They are and they aren't, right? They are because it kind of gives you that impression that they're behaving that way. There's no reason for ChatGPT to spit out word after word like like a human typing. It can actually give out the whole thing, but it's not. It's part of that experience that comes in. And I categorize hallucinations as the same thing. We tend to kind of want to give this feeling of like a human like, and we're saying, okay, this is an hallucination. I would say no, it's a bug. And why is it a bug? I would say it's a bug because, again, this is not a deterministic system, right? This is a stochastic system. We still don't understand, even today, by even the best of scientists out there who built these systems, do not understand how they work and why they work that way. They hypothesize based on the transformer model, but they don't know what happens inside. And so attributing that error or mistake as a hallucination is a nice way to think about it, but honestly, it is a mistake. So how do you know that something is a hallucination? It's an interesting thing, right? I mean, if you hear, let's say, from your professor, a sentence that states what appears to be like a fact, you're probably going to believe that outright, right? It's your professor. They're teaching you. So you know what that is. Now, if there's somebody else on the road, like someone like me who would come and say that, you're probably not just going to accept it for the fact. So what's the difference then between what your professor told you and what I told you? And why do you believe it differently? So hallucinations is something similar. So because of the nature of the way transformers work, essentially there's a stochastic model, which means based on a pattern, trying to predict what the next one is, or the next word or the next element is, and give you that, it's certainly possible for it to make up things. And yes, it does. All of these models do. They will make up things. So you need to make sure that you do understand how to deal with that situation, which is what hallucinations. And because of hallucinations, they introduce logic bugs. So you need to consider that is a big challenge that comes up. Trust and verification, again, so, connected to the same thing, you do have the issue of how do you trust an LLM that is going to give you the right kind of information, that is giving you, let's say, something grounded in fact, and how do you verify that? That's also important, right? You knew so far that when I produced a piece of software, you knew how to test it. You knew how to verify whether it did what you wanted it to do. How do you verify something who nobody knows how it works internally? So that's a great question, especially from an academic perspective, to think about how do you verify LLMs and the outputs coming out from LLMs. The third big challenge, which is very practical and very real, as you know, OpenAI and pretty much every other model maker out there has been sued by a whole number of people. Why? Because of what they call as data piracy. Because there's no way for these LLMs to work without having a large volume of data for them to be trained on. And how does one get all that data? Well, beg, borrow, steal from the world, because the world has that data. And that also has led to a lot of data leakage. So why is this important? Because, I mean, today in an all-connected world, for example, in India with UPI and Aadhaar and others, a whole lot of our information, including our biometrics, are lodged in some server somewhere. Now, that is a gold mine for an LLM. And this is where risks as well as regulatory aspects that play into data. How protected is the data? How does it work with this? So similarly, in an engineering world, with Copilot or with the models that were trained on code, where do you think they got the code? It's not that they were creating it all this. They didn't create all the code in the world, but they were training on them, which means there was somebody else's code. There was your code. It was my code. right? So we need to be a bit careful about that. The other one is in terms of, there is, it's human, I would say human-like and human behavior where, you're starting to see this chatbot, and maybe many of you use it every day. Honestly, I have a set of, as I said, alter egos that I surround myself with, and I use them every day for a number of different things that I do. So you have to be wary about over-reliance on this because it seems extremely useful and helpful. But you need to understand that that will not replace fundamental reasoning. The engineer of today is even more important for that engineer to follow engineering 101. So for all those, including me to a certain extent during my engineering days where I didn't pay that much attention to fundamental data structures, fundamental algorithms, please do, because that is even more important in today's world as compared to your ability to write a line of code. Honestly, whether you can write a line of code or not is not important anymore. What's important is how strong are your fundamentals of algorithms? How strong are your fundamentals of data structures? How strong is your engineering 101? That's critical because that is going to give you reasoning and is going to give you a fundamental understanding. That will allow you to build a trust as well as verify what these LLMs do for you. Okay. And lastly, of course, is prompt injection. Again, these are not an exhaustive set of challenges. There are many more than just this, but this is, just some important things to keep in mind. When Ajay proposed this and told me what the audience, in the session is going to be, I had this thing of saying, okay, what does it mean from an academic point of view, right? And this is not to say that this is something that the professors and the faculty should do. This is my interpretation of what could be things that could help from an academic point of view, which is one, we do have language coding classes. I think starting to bring in prompting along with that, I think, is an essential part that I think we should bring into our academic studies. Because it no longer, as we went through this, it's not about writing the code. It's about how do you take your intent and express that as prompts. So the ability to prompt, how do you prompt, not in terms of the, just the syntax portion of it, but more in the semantic sense of it. Similarly, when you do an assessment, and this is where I owe a huge debt of gratitude to one of my math teachers back in high school. She never cared about whether I got the answer right or wrong. The only thing that she cared about is how did I go about breaking down the problem to solve it. And that has stuck with me all through. And for me, even now, problem deconstruction is what I believe I'm really strong at. And things that is ingrained in my head is saying, I need to break down the problem. So, the whole thing, the assessment not being on output, but being on the process probably is a way for academicians to think about it. Given that coding is not the essential thing, provide ChatGPT or something else, during these exams to write the code. Because clearly it's the intent and the prompting and the design that's more important than the mechanics of writing the code, right? And whether projects are to be AI assisted with review journals and so on. So this is just my take on what could be some of the academic implications. Maybe some of this is already included, some things that are already being worked upon, but general food for thought. And as I said before, the reason why this is important is because you're moving away from syntax. Syntax has been king for a long time because of the world that we were in. You're now moving a whole lot more into semantics. And this means that when you're looking at coding, it isn't about writing the code. It's about how do you design your prompts? How do you express your intent? How do you orchestrate between these different things that are doing different bits and pieces for you, right? And similarly, from a debugging point of view, your output, the validation of the output, as when you're refactoring, how do you evaluate the diffs between the two as you're refactoring? Does that make sense? So on and so forth. When you're testing, can you give property-based prompting, which literally is like example-based testing, right? So it's a similar way, but in the new world. And when you think about your architecture, you need to think about it from a systems point of view, which is, I would want to repeat that as many times as I can. The systems thinking is critically important in this world, but you also need to consider what are the LLM constraints that come along with that. That's another thing to keep in mind. And this is something that needs to be, constantly, ongoing in that sense. We spoke a lot about, not a lot, but reasonable amount of challenges, safeguards, be aware of this. We don't know how it works internally. So yes, trust the thing but verify, so on and so forth. So there are a number of different, ethical guidelines, regulations, a lot of things that have been worked upon. One, of course, is from NIST. The AI risk management framework is one such thing. It is a good exhaustive document. It's something that'll give you that. There's a lot of upkeep that's happening there. The IEEE 7000 standard is another great one. Again, I don't come in from an academic point of view. I'm looking from a practical point of view, but these are extremely useful, especially when you're growing through the academic, I would say, portion and getting into your career. These are important. And as you go into, let's say, what does it mean on the ground? You have offerings like Guardrails AI, which has a way to, an open source, a way to validate what LLMs bring out. And that's also important. So these things need to be kept in mind much more, or in fact, maybe even for some of us for the first time, because we never needed to in the old world of the SDLC. In the new world of the SDLC, this becomes important. So these are things that you have to inculcate into how you do that. And how do you learn? I mean, when I was growing up, I think, so I took on a course during my days. There was computer science. That was the only real computer science one, which I wasn't too thrilled about. But there was a course from Bits Pilani, which was the information sciences and technology, which kind of taught me the systems and software and things like that. But the learning modes and the models, even then, were kind of more, I would say, not as much of doing it while you're learning it kind of thing. And this is where I think we need to think about what is the kind of learning models that we have or that we should have going into the future. So you look at pair and peer programming with agents, because that is a reality, like what you saw with the video there. That is a reality. All of us are going to have agents for different things that we're going to do, or alter egos, as I call them. You need to look at how you flip the prompting. How to communicate with with your LLM model and look at that. You don't review code, but you're going to review prompts. You're going to review approaches, so on and so forth. And then, of course, a lot of research areas around, how do you build trust models? What is the best way to benchmark what you get? Is there a way to predict hallucinations? Is there a way to eliminate hallucinations? So on and so forth. So again, the learning models and how we look at it, how much of this is maybe already going through a change in the academic world? Maybe there's, food for thought and something more that we can do around this world. That's, again, something that I would want to leave, especially with the faculty and the academy out here. So, what does the road ahead kind of look like? The road ahead for, the way that I look at it is that you're going to have more and more agents, and, these agents are going to improve. They're going to work in an autonomous way. You're going to have IDEs as an integrated development environments. You're going to have development environments that are going to debate your architecture, right? Today, nobody does. Today, you do it among peers or peer humans, but tomorrow you're going to have, the piece of software that you use to type your code into is actually telling you, or is arguing with you in terms of saying, maybe you don't want to do that. Maybe you want to think about it in a different way. That is the reality where we're going to go, come up with. There is definitely going to be evolution in terms of like explainability of the models and how it came up with a certain bit of logic. I'm hoping that the researchers and the academicians are able to crack how LLMs actually work internally, so that as humans, we tend not to trust things that we don't fully understand. So I'm hoping that there is some way that comes out of it. And lastly, we already have this, and you're going to see more and more of this, is these co-pilots or these agents or these alter egos are going to be on all edge devices. You already have them today to a certain degree on your phone, in your, let's say, your Meta Ray-Ban glasses, or the Aura rings. That's just going to go more and more. OpenAI made a recent acquisition of Johnny Ives, the famed designer from Apple, and likely that's going to be the first no-screen phone that's going to come out. And so these are all evolutions which are going to make a lot of these things available at the tips of our hands and our fingers and our eyes and our ears. Our typical human sensories are going to, I would say, be lambasted by the number of different devices and techniques that are out there. So this is only going to grow more and more and more. And so what does this mean for us? This is something which is like food for thought, and something we need to ponder, not just now, but as we go along, which is, you can't stand still. I mean, for every one of us who's in technology, I think this has been true for the last 40 years or maybe even more. You can't stand still. But you do want to be a little skeptical. I mean, skepticism and curiosity and things like that, honestly, for me, were I would say, underlying things that I was taught and I was kind of like drilled into my head, very early on in my learning period. And this is something which I would always say, be skeptical, do not stand still on that, right? If you can, and to the extent that you can, engineer the engineer of the future. And this is important now. We are about 2 to 3 years into this new world, which is a huge inflection point. What does that engineer of the future look like? This is something that we all need to be a part of, and we need to engineer that future for ourselves. Don't use tools. I face a number of clients. I face a number of different people within my professional network who tell me saying, "Oh, it's another tool. Just give them the tool and train them on using the tool." Actually, this world is not about learning the tool. You need to learn how to use the tool. And the using the tool is not a deterministic set of things. As saying, if I want to use, let's say, Outlook and I want to send an email, it's easy. Click on new email, type in this or to, type in the subject, type in the body, and click on send. In this world, that is no longer sufficient to know the tool. You actually need to know how to use the tool, leverage the tool. So that also means understanding what the limits are and so on, right? And the only way that you can do this, I think, is the most humanness of things that is ingrained from us when we are children or when we're babies. Curiosity, right? We're reaching out, touching and seeing, we're smelling stuff. That curiosity needs to remain. You need to build verification now into that as a constant thing, not as that you don't trust anything. You don't want to be that cynical person, but you do want to verify a lot of these things that come on. So curiosity and verification, I would say, the two key things, from a mindset perspective that you need to shift to if you're not already there, and those will serve you well in this new world. And that's extremely important. So that's all that I had for today. I hope I did okay on time, Dr. Ritika.
Thank you, sir. I'm sure this insightful session has enlightened the participants about the actual scenario. There are a few questions by the participants, which I'd like to now take up with your permission, sir.
Sure, please.
First question we have, how are Indian software services companies gearing up to be ready in this new co-pilot world? How are they upgrading their engineers to be at scale with this AI-driven SDLC?
Yeah, I think a quick Google search, which is also kind of going through a whole lot of changes in this AI world, but a quick Google search of, I would say, statements that have been made by a number of Indian SIs goes back almost like 2 years, or even at the very start of this whole new world. Every company, including the company that I come from, has been at these efforts quite significantly. But having said that, this is not an overnight journey. This is not just a new language to learn or a new tool to learn. This is a journey of learning. And I would say in many ways, this is a learning journey that is as involved and maybe even as longer as when we went through school and college. And the reason I'm saying that is because this is honestly new things that we need to learn, new ways that we need to learn, and it's still an evolving world. So the extent of effort being put in by Indian companies is phenomenal. There's a lot of effort going in. You may not see outcomes immediately because that takes time for people to change. And the second part of it is that if you look at the Indian startup system that are in the space, there is a number of them, and there are new ones coming up. Some really nice, very interesting ones coming up.
Absolutely, sir. So the next question I would say is, there are so many tools to choose from, each of the big companies like Microsoft, Google,
Yeah.
OpenAI. How do we actually make the right selection?
Yeah, that's a great question. And from my past company, there was a quote that came out from them, which was, what they call as tooling fatigue because of tool churn. And that honestly is true, especially because we are seeing so many tools come out almost every day or every other day. Key part is not, again, so much about the tool, but it is about how you leverage and you work with those tools. So yes, don't be swayed by saying this tool is better. It's the same thing with models, right? OpenAI says today, my model is great for coding. Claude says, my model is great for coding. Meta says the same thing. This is going to constantly happen. We're still climbing up the hype curve, or I would say kind of getting towards, the plateau up there. It'll start to dip at a point in time. Don't get caught up in the tool churn. Don't get fatigued by it, because your value and what you bring to the table is not based on the tool you know. It's based on how you leverage the power of these kind of tools.
Absolutely. Sir, the last important question is, the common rule of thumb is that ChatGPT uses 10 times as much energy as Google search. So if we talk of in terms of sustainability or carbon consumption, is integrating Gen AI into SDLC actually going to be a sustainable alternative for humanity?
Yeah, actually, it's the kind of questions I tend to kind of shy away from, because I don't think I'm an expert or can offer much of an deep insight into it. I can give you my take on that as somebody who's, let's say, a practitioner in that sense. Yes, I think the concerns are very valid. I think humankind is going to figure out a way to come out of it, because this path to there is inevitable. You're not going to wish this away. It's not going to go away. So rather than asking the question of saying that, is this sustainable? I think the question is, how can I do, or what can I do to make it more sustainable? And there is already a lot of evolution happening in that space, in terms of like how much of what is the kind of energy that should get supplied to these kind of data centers that make this processing. How do I distribute the computing power? Which is why we said edge devices also getting much more smarter. You have small language models coming up. So it is changing the way computing is happening. So I think it'll take a little bit for the computing power to kind of get distributed across this network, while I'm sure there are going to be more sustainable ways to generate power.
Absolutely, sir. Very rightly said. And thank you so much for this wonderful session we have had today. I would now be inviting Professor M.N. Huda, sir, to kindly present a certificate to Srinivasa Bhaskara, sir, for this wonderful session today.
Thank you very much.
Thank you so much, Mr. Bhaskar. It has been a
Thank you, sir.
fantastic talk. And certainly, I also believe in the same philosophy, that it is not the tool which is important. It is the skill to use the tool which is more important. We must learn how to use the tool. The tools are many. Are we in a position to tap the full potential? You rightly said. You explained in best possible manner and the most simplest manner. But I look forward that the journey of the change, which has traveled from keyboard to prompt pirate, has to travel a long way ahead. Because the kind of the researches which is happening in cognitive sciences, probably even this while typing the prompt pirate and a kind of the Gen AI concept will fall short of the innovations which is going to come up in coming days. So when those period will be, then we will be, during those days, we will be realizing that this wonderful talk, when that was the beginning, was great help to each one of us as part of knowledge dissemination. Thank you so much. And this certificate is in no way a certification. It is primarily for the remembrance, that when will we recall and remember and cherish this webinar, this certificate will remind us and will become a point to cherish. Thank you so much. May I have memento, please?
Yes, sir.
And again, the memento is also as part of the same remembrance series, not for the purpose of giving some certification. And Mr. Srinivas, you might have observed that right from bouquet till the memento, including the talk, everything is electronic. And that is also a part of the same change which brought us from keyboard to prompt kind of environment.
Sure.
So everything in and around us is changing, and we are part of that change. We are committed to be adaptive into the nature, and then only will be relevant. And those who will not adapt to these changes will left too behind. Thank you so much. Wonderful to have you on this platform of BBICAM IEEE webinar series. And dear friends, this meeting room is converted into a facilitation center. Guests are on their liberty to leave the room. Those who wanted a certificate, you need to fill up the feedback form, which is link of which has been shared in the chat window. My colleague and Dr. Ritika Vasan, Deputy Director from the Institute, shall be looking after and resolving your queries. Thank you so much. We'll meet you all during next webinar. Thank you so much, Mr. Bhaskar. Now,
Sure.
depending upon
Thank you all.
Oh, thank you so much, Ajay.
Thank you, Srinivasa sir. Thank you for the
Thank you, madam.
wonderful session. And we hope to have more sessions with you in the future. So thank you so
Sure,
much.
I'll be honored to. Yes, thank you so much.